Hey everyone, how's it going? Welcome to the stream. All right. So let's pick up where we left off last stream. Last stream we were trying to figure out why Bedlam, the game Bedlam, would not start a second round correctly. So let's demonstrate the bug so that we can get back into it. Here, let me disable some breakpoints, of which I seem to have many. Okay, so here's Bedlam. We get started. Hey Pyro, how's it going? So here I'm gonna die. And then when I try to go again, I hang like that. So you have a bit of a headache? You know what? So do I, to be fair. To be honest, I'm a little bit tired. I have a cup of coffee here and I'm hoping that's going to help me. I almost didn't stream, but I decided to stream because starting next week and maybe for a couple of weeks I won't be streaming because I'm going to be just taking some time off, a little break with my family. We're gonna, head out to a few different places. So I figured, tonight might be my last stream. Maybe Thursday night. We'll see what happens. But if not, it'll be a little while, like a few weeks, and I'd be back at the end of August or something. So I decided to give it a go, and I'm hoping the coffee will help. If it doesn't help, I'll probably end my stream early, but we'll see. We'll see what happens. Yes, thanks. I do think it's a well-deserved vacation myself. It's been a long year. But yeah, it's nice to spend some time with the family. All right, so yeah, I did a little bit of marking up last time we were working on this. Since last stream, I haven't had much time to look into this, but I did read as many places as possible to figure out whether or not my implementation of the CWAI instruction was correct. And the reason why I'm pointing at this, let me see here. What did I do here? Oh, this was just me trying to detect stuff. Yeah, nothing useful. So yeah, because I'd figured out that there is a fix, and I put that in quotes, air quotes, fix. And the reason I do that is because I really don't believe it's correct. See, if I just swap these two lines right here, so that when CWAI happens, we push the current state, the state of the control. What's TC stand for again? I always forget. It's basically the state's condition code register. That's it. The condition code register. If we push that before we AND the value of the condition code register with the immediate value, then this actually fixes the bug. But it's not. I'm like 99% sure it's not right. Based on everything I've read. So like it's gonna work, but like I'm not satisfied with the fact that it works. And I could probably get away with it because I don't think many games use CWAI, but then I think there's gonna be another game that doesn't work because of the real source of the problem, the real source of this bug, See, now it looks like it's working, right? But I mean, it doesn't make sense with what I've read. It looks like you really are supposed to first and your immediate value with your condition code, then push it to the stack, and then wait for interrupts. And then when an interrupt occurs, at that moment you you forcibly set interrupt mask to 1, and then you run the interrupt. And when it returns, then the interrupt mask here will be like set to whatever was pushed on the stack. And not interestingly, but I guess most of the time, like in the case of what we're looking at, I mean, it means that it's going to go back to 0, because when people use CWAI, they use it and end it with a flag that effectively says either enable interrupt mask or enable fast interrupt. So Pyro's saying that's different from the docs, right? Yeah, so different from the docs, meaning like if I were to move this, if I were to move this down, this would differ from the documentation. The documentation, all the docs that I've read say that it's supposed to be this order, that you first end with the immediate value, then you push. So if that's what you're saying, then yes. And so what does this mean? So this means that what I am seeing is that for Bedlam, where they use a CWAI to basically do the whole render loop of the game. And it may actually be more than the render loop. I think they do the whole frame of the game on this interrupt, you know? And basically they constantly are calling CWAI, then they wait for an interrupt, and the interrupt they're waiting for is timer 1. So they set a timer, and then when it comes back, then they run this long interrupt handler, which basically does like all the drawing. So I think that's what they do. They do the drawing through it. And actually, I'm not really sure why they. I don't really know why they do it this way. I think it's the only game I've seen so far that does it this way. But the point is that when it's over, the interrupt mask remains 0, which means that any other interrupt that is to occur is going to cause this IRQ handler to run again. And that's fine. I mean, that's the way the game is supposed to work. What's not fine is that when the game is over and we are in that, that kind of title screen and we press go, before the game gets a chance to run, we're in this kind of in-between state where I believe that the game just doesn't expect the interrupt mask to be 0. It expects it to be 1. And I say that because it runs through this code, which is I think in the BIOS, it's a BIOS routine to reset 0 ref. And part of that, there's like a kind of a tight loop where it just kind of reads, it pulls a value from the VIA for the timer value. And when it's doing this, the timer the timer interrupt keeps getting run. So there's something wrong going on there. So that's kind of like the summary of where we're at. So here's my feeling. My feeling is that the CPU is fine. My feeling is that the interrupt mask is supposed to be low during gameplay, and something is supposed to set it back to 1. Or the other thing that it can be is that maybe it just remains 0 all the time, but what's happening is that we're not supposed to have interrupt enable set on the VIA. So something should have been writing, I believe, to the interrupt enable and kind of unsetting the flags in there. Because if interrupt enable on the VIA, if this register were to be cleared, like if all the bits for the interrupts were cleared, then it wouldn't matter that the interrupt mask bit is low on the CPU. There would be no interrupts that would occur. So that's what I'm going to see if I can figure out what I'm going to focus on the interaction of the game with the interrupt enable register and try to figure it out from there. Because honestly, I'm kind of running out of options. I mean, I'd have to think about different ways, but if we assume, because I've been looking a lot at the CPU, right? The last few streams we've been staring at I've been staring at CPU traces, and there's nothing that looks like it wants to set the interrupt mask back to 1. I thought for a little while that maybe there was like an op reset, there was a reset call, because there is a reset instruction, by the way. But the reset only happens when you physically press the reset button. So it doesn't look like the ROM is trying to invoke reset. But if it did, that would be at one place where the interrupt mask would be reset back to 1. I have this reset call here, and I do call it an op reset with a little comment that says, I think this is right. But I've never seen this actually called. So I don't think that's what's happening. Op reset would be called here. Page 0, instruction 3E. Doesn't look like we're getting that. So yeah. So let's put some focus on the interrupt enable and see what we get from that. Yeah, Pyro, that's totally valid too. That's true. Yeah, it's true. It would be useful to have like a working disassembler, which I don't really have. It's a valid point. That's true. I wouldn't be able to see it in my debugger. One thing I've considered doing, so I'll look a little bit at the interrupt enable. One thing we could consider doing is, let me bring this here. Where is it? Here. Whoops, no. What did I just do? So V-Day, the emulator and kind of development environment that I've shown before on this stream, that Malban has put together, it has a pretty cool integrated debugger, and we could, you know, kind of like compare what the state of the registers are at and stuff like that when the game is about to begin, and I can kind of pick, you know, a starting point from using my debugger and then try to put a breakpoint there in his and kind of inspect data from there. So that would be something we could do. But let's just start by trying to see if what my emulator is doing in terms of the interrupt enabled. Maybe we'll get something interesting there. All right. So I'm getting a store instruction here that's writing to there. Let's take a look at where we're at. Clean up a little bit. Okay. So we are in the game ROM at hex address 41, or at least the one right after that. Oh no, I think we are there. Let's see. No, actually we're not. We would be at... (3E). Yeah, 3E is doing this. So let's see, we'll break into the debugger here. Okay, let me take some notes down while we do this. Okay, so these are my notes from everything we've done so far. I'm gonna put a little break here. Yeah, so Pyro, you're right. I would be able to make a basic disassembler. However, because like unlike, you know, certain architectures like in, you know, 8086 and stuff, these old systems kind of mix instructions with data quite a bit. You know, like there's just no way to know for sure. What often ends up happening with a basic disassembler is it just doesn't work. And, you can't just kind of process the whole byte stream and say these are all instructions, because in there may be data. So you have to kind of say like, oh, yeah, I think you see where I'm going with that. I tried to do that for the NES. I thought, hey, I wrote a cool disassembler, and then when I started using it, I realized it wasn't working. I kept hitting, illegal opcodes and illegal instructions, but it turned out it wasn't illegal instructions. It was just I was parsing data. Yeah, so there's no way to know. You know what I mean? There's no way. It's not like on 8086, I think, right? It's pretty. You kind of separate the data from the code, and you can figure out like this is all code, right? But for these old systems, when you write your assembly, you can be like, oh, at this address, I'm going to put some data, and then here's some code, and then here's some data, and here's some code, and so it's difficult. You can do it. It's just much more complicated. You have to kind of start analyzing. You have to assume at least as one starting point, which is true. You can assume, like, I think in this case, at address 0, there will be code, And then what you do is you run and you look for any operation that is a jump, right? Any kind of jump or call to a subroutine or anything like that. And you try to say, you try to jump there and you analyze those as instructions, and then if there's a return, you can continue where you were. So you kind of have to build almost like a stack of your parse to try to put together the pieces of the data that is actually code. And anything that you don't run, so if there's any branches, you have to explore all the possible parts of the branches, so the true or false part. And you can do this. It's kind of an interesting project, right? And you explore all the code. There are some tricky bits in there because there are some ways there are like some tricks, right, to be able to return to where you were without using the proper instructions. Like you can just pop off the return address and I forget, there's some instructions to do stuff like that. So there's like tricks to take less cycles, and you have to like detect those to make sure that you capture all possible ways to jump around your code. So there's that. But then there's also special case for interrupt handlers, right? So you have to look at, that's not too bad, but you look at the interrupt table at the end, and if they're valid, and that you don't really know, Yeah, reading the stack pointer and jumping, exactly. Yeah, so you look at the interrupt vector table, and it's possible that some of those just have garbage values in them for whatever reason, because the program never uses them, and you might end up parsing code that, once again, that's not real code. So if you're unlucky. So yeah, basically, I guess what I'm saying is it's not that simple. It's a bit of work, But one thing we could do is look to see if somebody else has done that work. I mean, actually, I wouldn't be surprised if this tool, this V-Day tool, has something like it. It's really quite featureful, the whole idea behind Malbin's work here was to make a fully integrated development environment so that you can make make Vectrex games. That was the whole point of this, But I mean, I love the idea, don't get me wrong. Yeah, I know, Vectrexes are really expensive. Like, I know I could sell mine for around that price. And I have like 6 or 7 games or something. Yeah, I mean, they're really rare. They're hard to find, so people can sell them, and they're still in high demand because they're kind of cool still, right? They're cool machines. You just happened to fall upon that on eBay, or did you like look for it or something? Okay, you were looking for retro consoles. I'd like to find. So the one interesting thing is I've also been kind of looking. I've been looking for a. I'd like to get like an NES that I could plug to my HDMI, you know, my TV, and I'd like to get a real NES that you can pop cartridges in, because I have a lot. Oh wow, Michael C, your dad has 2. Oh my goodness, that's crazy. So yeah, like so yeah, I was looking for a NES because my kids, like I like to play video games with them, and I like to show them a lot of the old games, and I grew up playing a lot of NES, so I have all these games. I have an old NES, but it's really finicky. I've raised all the pins, but it's still kind of hard to kind of pop the games in and make them work. You got to play with it, not blow on the cartridge, of course, but if it's not quite lined up, it doesn't work, and so it's a bit annoying. And I want to give my kids the experience of like grabbing a cartridge and sticking it into a machine, pressing power, and boom, you're in the game. The experience that I had growing up with carts and old consoles, because there's something that's definitely been lost with modern consoles. Having to power on and get into the OS and then go through it, and maybe you have a CD for your game, or maybe it's downloaded, and then you select it, and then you wait for it to load, and then you go through like 18 logo screens, and then eventually you get to the start thing, and then it tells you, oh, there's an update, and then you download it, and then you wait, and then finally you play, and it's just incredibly complicated. And there's just something so nice and simple, about the old games. And for young kids, that like the lack of barrier to entry is just so important, So I'd like to give them that feeling. But I'm looking online, and it's kind of tough because you either get these like really cheap NES like things for like $40 that don't really work that well, or the colors are off, or it's emulated so it's not great, or you go to like $150+ for like an FPGA NES thing that's super awesome but extremely expensive, So I don't know if I'm ready to spend that kind of cash just yet, Yeah, exactly, Pyro. That's what I'm talking about. There are a couple of really cool FPGA. There's one that's like $450 US, and it's amazing. But my goodness, it's more expensive than buying a PS4. So anyway, a little bit off topic there, but that's something I've been looking at. Yeah, I don't really feel like modding my NES, and that's the thing, I don't really want to use my NES. Like I said, it's too finicky. Unless I can really make it easy and 100%, where you can just pop in a cart and it always works, I'm not really interested in using my old NES. I prefer like to have a top loader, one that just works, You put the game in, you press power, and it's on. There was like an NES that was gray, and it was out for a while, and it was a top loader, more like its Famicom cousin, right? And I don't know where to get that kind of thing. So I'll keep looking. Interesting. Okay, so this... Oh, I think it auto-started. So where are we now? We are about to... Why am I... Okay. Okay, we're about to enable the interrupt for timer 1 here. Yeah, 140 bucks. So I find that a little bit on the expensive side. And maybe it's okay. Maybe I should just invest. Still thinking about it. But, you know, it's kind of like this threshold where you're like, well, if I'm going to spend that much money, maybe I should spend a little more and get the best thing, you know? But then... And then there's also the thing of like, do I want my kids to like be playing with a really expensive console like that, which, you know, they're a bit young for you know, handling this thing properly. I would need it to be extremely robust, you know. My Nest took quite a beating when I was a kid. It would fall down and all kinds of stuff, and you know, because you know how it would be, right? The controller would be too short, the controller cord would be too short, and then you'd end up pulling it, and then the whole Nest would drop from its perch and bang on the floor, and that happened quite a few times, and somehow the Nest survived for like 20 years. So if there's anything built that way, and it's even if it's expensive, maybe it's worth it, you know. So let's see where we are here. Okay, so we're now at 0.53, so that's a different place, yeah, because here now we're no longer, we're going to be doing this here. Game start, IR is modified to enable T1 interrupts. And I believe this is right. Let me see. Bit 5. Oh, timer 2, okay. T2 interrupts. Yeah, that's true. That's a good point. I could maybe do that. Then we continue. This is the game. I want to see if it goes back to title screen without me pressing. One thing I want to look at here is that I say via interrupts enabled 20. Why did I say 20? Is that right? Yes, okay. And it was A0 because it was to enable that one. Yes, okay. So that would be the T2 interrupt. Okay, makes sense. Okay, it looks like it's not going to go back. Maybe there's a timer though. Give it a few more. Yeah, so that's an interesting idea. So get a Japanese NES because that is a 60 frames per second. It's NTSC, and then I'd have to mod it for the HDMI. I'd also get the advantage that I could play. So does the Famicom play NES carts? Like, is it? I don't even know. Is the form factor good for that? Like, does it fit NES carts? Okay, it looks like it does wait. So I'm gonna press A. Okay, so here we are again. What are we doing? So here, value for interrupt enable is 127. So that's different. So we're actually going to. Okay, this is a clear. This is just like, okay, this is just like what we were doing before. Isn't that good? Yeah, this is good. So we are clearing it here. And are we at the same place? E. We are. Maybe you could find a cheap Japanese NES and mod that one. Same voltage too, right? Right. Yeah, I probably need an adapter. That's not a big deal. But no, it's more like, can I play my NES carts on there? Because I don't have any Famicom carts, you know? The good thing would be, of course, I was going to say, is if I did get my hands on a Castlevania 3 Famicom card, I'd get the extra 2 channels or 3 channels of audio that they put into the hardware in the cart, which is kind of nice. Okay, so this is interesting. So game over, press 1 to go back to title screen, and we get, and we reach, and we reset IER again at 003E. Okay. So it's interesting. So we are here. And auto started. We're back exactly as before. And I don't think this is the problem. What's up, Gabe Doggo? Don't think I've seen you before on the stream. How you doing, man? Yeah, so I think we're back exactly where we were before, and I don't think this is the problem. The only difference between the last run and this run, glad to hear it, Gabe. The only difference between this run and last run would be that now the CPU would have its interrupt mask at 0, which means it would start immediately getting interrupted. But it's kind of interesting, right? Because so, okay, let me just write this down and then I'll finish my thought. So let's see here. What I wanted to do was here, like that. Yeah, exactly as before. 0053. Then start, and again 0053 executes, and we enable T2 interrupts. Okay, so here's what I'm realizing, and this comes back to what we learned last time, is I don't see the problem being with the interrupt enable necessarily. Oh, can we see it here actually? I should actually have marked this down. Yeah, I can still mark it down. Here we go. We'll see it. So you see, first time around, the difference between the first time and second time, once again, it's this little I over here. Interrupts are masked out here, interrupts are not, right? And so it's kind of weird, right? Because it means that the game would go ahead and say, all right, we want to get interrupts here. But then from now until the time it calls CWAI, any interrupt that would occur will be handled by, well, like any interrupt, and what I mean by that is, so this is what's going to happen. This is why we get stuck. If I continue, I'm going to show this like this. We're going to go to CPU. Like basically there's two parts to this interrupt story. One part is we tell the VIA, I want to enable interrupts for T2. The other part is that the CPU is going to call CWAI and pass it a mask pass it a bit mask in order to enable interrupts, like enable IRQs. It's going to say set the interrupt mask to 0 by ANDing it in on CWAI, which means that between those two, it's expecting the interrupt mask to be 1. And that's where, so we're gonna I guess we are gonna end up comparing using VDay. But I'm just gonna show you what's gonna happen here. So what's gonna happen is we're gonna end up entering in here when we don't when we shouldn't, as far as I'm concerned. And at least it's not the same. Like we're gonna end up executing this IRQ on the second time around when we wouldn't have on the first time around. So if I continue, so here we are. We're about to execute this IRQ now because our interrupt mask is 0, and we just got a T2 interrupt from the VIA. But if we look at where we're at, see we're at an instruction that is in the BIOS, F1A0. So let me make some sense of that here. So I'm gonna do like this. So here we are, we're in the middle of processing a loop actually in the BIOS over here, and like during this loop we are not supposed to be running our IRQ handler. So let me see here, F1A0. So we're in wait recal. Okay, this function, wait recal, is wait for T2, the refresh timer, to time out, then restart it using the value in C8-3D, then recalibrate the vector generators, blah, blah, blah. But the point is that in here, let me see here, F1A0, then branch if not equal. So branch not equal back to here. So that's it. We're in these two instructions. And what this does is it polls the VIA interrupt flags to wait for T2. And of course, it's waiting for T2, but if once T2 raises, we're getting an interrupt handler run in the game. And that doesn't happen the very first time around. And this is why we get stuck, because we're in the middle of recalibrating and then all of a sudden we try to run a render of the game, right? And then we come back here and we just never move forward. We're not in the right place, So there's something going on there where, as far as I'm concerned, I should not be 1. when it loops polling for T2 to be enabled, as soon as it is, the game's IRQ handler runs when it shouldn't. Oops. So this comes back to what's going on. All right, so let's see if we can use the debugger from VDay to figure this out. Or at least, because so VDay's emulator works. It doesn't seem to suffer from this problem. I've tested Bedlam in there, works perfectly fine. So maybe by running this we'll be able to see what's going on. So you can see I even have Bedlam already loaded. Yeah, this is this assembler here. The registers. I don't really remember how to use this thing, but let's see. We'll figure it out. Oh yes, I think I have to hit this, and then we break into the debugger. This is really nice, by the way. I really like this debugger. It's kind of cool. You have like, there's these tooltips that show up in certain cases that give you like extra information. All right, so what I wanted to say here was, let's see if we can put breakpoints. So it'd be nice to break on 003E. I guess it's a watch. How do we add a watch in here? Set current, no. Oh cool, show via monitor. Oh, that's nice. That's handy. I have been thinking that one thing I'd like to add to my debugger is a way to, because right now I only show the state of the CPU, but I think it would be really interesting to be able to look at the state of the VIA as well, and that's exactly what I see here. A nice visualization actually of what's going on in the VIA itself. It's really nice. Okay, so let's see. How do we set breakpoints? So I can set a breakpoint on the set to current selected address like this, but that's not really what I want. Is there like a breakpoint window? Debug window, which is what I don't know what that is. Tracker. Vectrex DC, disassembler, registers, VIA registers, analog stuff, log window, okay. Show breakpoints. Okay, so here's, maybe I can just do it this way, add some random breakpoint and then change it. No? Nope. Just don't know how to use this thing yet. Surely it can't be that complicated, right? Maybe I can, maybe the trick is to go to the address. Yeah, maybe there's a way to like, What was that? Cast a code, cast a byte, watches, use label as data. Search. Here we go. Not found. No? Okay, so it doesn't, this searches, I think, for labels, but it doesn't search in here. Okay, here. Via interrupt enable. So there's one. And then 0053, which shouldn't be too far, right here. All right, so let's, can we restart? Oh, did I lose my breakpoints? Really? That's not cool. I did. Really cool. Just need to figure out how to use it. These are the two I want. Oh, okay. Looks like we did hit our breakpoint at 53. Okay, so we missed the first one, but at least we can look at what the state is at when we hit the play, which is this one here. So at this moment, if we look at I, let's go to our registers, and we look at CC, and then I is which bit again? So we've got all ones. I think it's masked up like mine. So that's going to be 0, 1, 2, 3, 4. Yeah, so see 1 is high right now. And that's good. And if we continue, so how do we continue? Single step, overstep. I don't know what the next, I don't know how to continue. So you can do single step, but we can do overstep, next instruction, breakpoint, PC +1 instruction. Up here, you mean? I don't think that's it. I think we're broken into the debugger here, and I gotta like continue, but I think if I press play, see, it still breaks into the debugger. I need to tell it to continue. So you have step out, which I don't think is the right one. Maybe this? Multi-step? And it's actually like doing stuff. Maybe I'll do this. Okay, it looks like that's what it is. You have to like break out. Okay, this is like debugger mode. So if we turn it off, hopefully it'll hit the breakpoint. Just let it break. Okay, so now if I okay, so cool, we're back in the debugger. And see, the mask is 0 here. Oh, that's interesting. That's just like me. Okay, what about, yeah, so then what? That's interesting. And see, when we reach the 53, just like for me, bit 4 here, it even said, oh, there you go, if you hover over, it says IRQ mask is clear. So then ostensibly, when it's going to run, it should run the, okay, so let's see if it gets into the IRQ handler. And what I should have done is actually put a breakpoint in the IRQ handler here. So let's do that. So that, where is it again? CFB8, CBF8, okay. Why don't I? Okay, so it's a 09B9, actually. 09B9. I'm not seeing it. 09B9 here. No. Huh. Has a jump to 09B9. So it could be that it's the disassembler here, you know? This is trying to disassemble. This is back to what we were saying. Maybe at this moment, it doesn't know. hasn't figured it out yet. Because you see here, the fact that there's a 10 in the byte of the previous one, I don't know. C1D. There's an RTI. So that's the end of the interrupt handler. So somehow I can't seem to get the beginning of the interrupt handler correctly. It's 99 in here. I guess I'll put a breakpoint on both of these. I don't know. Okay, so let's see if we hit IRQ. What am I looking for? Will I be able to know when this happens? F19E. Let's go there. Okay, so this is the wait recal function. And then we're going to keep looping here until, and then once we're done, we should come here. To set refresh, yeah. Okay, let's continue. So we are now in the middle of doing this loop, where we're going to keep polling. So I'm going to remove this breakpoint and see if we hit our IRQ before we get to set refresh. And we didn't. Interesting. Oh, but look. Oh, IRQ mask is set by now. Aha. So something did reset the IRQ mask. Well, that's interesting, right? So there is an instruction that I'm not emulating correctly that would be resetting the IRQ mask, or that where like Pyro said, maybe we're just not executing that instruction. Okay, so how do I find that? Maybe an OR CC? I don't know if there's a way to set like a watch point on a register. That would be super cool. This is the stack. Maybe there is a way. There is a watch window, but what I want to see is what instruction would have modified this CC, right? Which is a register. I don't know why, like there's like a plus here, as if there should have been a way to add breakpoints. You know, we can remove breakpoints. Why can't I add them? We're broken into the debugger. Trying to think how we're gonna figure this out. So after the after it sets the IER, there's something that runs that makes sure to set the interrupt mask. Yeah, probably Malban will tell me that. Okay, let's read the fucking manual. Okay, so let's see here. Oh, that looks interesting. This is the beginning of a breakpoint list window. Although it is functionally working, I don't like the looks of it. The display lists all known information of all breakpoints, although to normal users information may seem cryptic. It displays all known breakpoints in a list. The current break is highlighted. To delete a breakpoint, press the notice. Not all types of breakpoints are implemented yet. Some of the more cryptic information. Memory. All breakpoints relate to memory. CPU. All breakpoints relate to CPU. There are possible subsystems. Cycles. Special. Okay. So it looks like it doesn't have a breakpoint for CC. Which is fine. I mean, I don't have one either. So I'm not surprised. Not implemented via, only via or ORB implemented. So okay, so there won't be a way, it seems, at least if this document is valid, is up to date, to be able to put a breakpoint on that. The thing is, there are not that many instructions that can manipulate it. So I was trying to do a search. You know, there's AND CC, there's OR CC. Obviously, there's CWAI, which is typically used not to disable but to enable. But why are they not finding it? That's really strange. Not found. Am I doing something wrong here? Okay. I have to click in the mnemonic to find it. Test. So it's not really searching in there. So DISI only shows sensible data that was loaded from a file. DISI does not read data from the emulator. All addresses not loaded are marked as unknown and contain, for the purpose of DISI, only a 0. It means it is not possible to look at RAM or I locations, and per default, these are hidden from view. It assumes the file is a valid Vectrex file, meaning it searches the start of the file for a Vectrex header. Assuming code thereafter in general is kind of difficult because if data is encountered, see, this is exactly what I was saying, Pyro. See, it assumes, because if data is encountered, DISI tries to interpret data as code, and that looks most of the time pretty silly, so please help DISI. DISI always tries to disassemble the files so that ASCII can compile the generated source to be 100% compatible, 100% the same binary that was given in the first place. It says you need to help. Yeah. So it looks like there's a way to mark data that in there so that it can track it. Yeah, exactly. That's exactly what I think too. Such a cool project, I have to say. Malban, if you're watching, this is amazing work. By the way, Malban has been working on a game for a long time, and he shares it on the Facebook group of like Vectrex fans there, and it's really cool. It's a space shooter. It's a shoot 'em up, and it looks amazing. I should try to find the video of it, but he's not quite done yet. But it's really cool. I'll try to share that at some point on the stream. I don't think my emulator can run it though, because I'm pretty sure he's using bank switching, and I haven't implemented any bank switching whatsoever because like very few games actually use it. It's more like modern games like Homebrew that does it. Okay, so let's see. What could we do? So definitely something changes. So why can't I search? I mean, honestly, if I could just search for some instructions, that would be all I'd need. Does it only search comments? So searching is working, it finds comments, but found in comment, okay. EQ. So it doesn't search in mnemonics. And you can see here, by the way, like all the DBs here, if these are indeed correct, you can just see how like data is interspersed with instructions. Maybe there's some notes about how to search in the help. Yeah, where did I do the help? Okay, let's see if we can find anything about the search in the Dissy window. Dissy, where was it again? Here. Oh, look, you can actually, there's even a, similar to mine, you can actually enter commands here. Okay, so I could do a reset here. So nothing about the search in here that I can see. Yeah. You know what, maybe if I copy paste it, does that work? Oh, it does work. Sweet. So maybe we can find what we're looking for. So ORCC, aha. So we can figure out what this says. There we go. Oops. Don't know if these are valid, but there's RCCs in a few different places. So 0E33, that looks promising. So this would do what? 1E. See, that would want to turn on that bit. So that looks really promising. 0E33. Let me see. Anything else? There was this one here, E767. There's one at F924. Set carry, but this is ORC1, so that's not interesting. ORC1 not interesting. Yeah, it looks like this one is the one that would be most interesting, and it's in the program itself. So let's see if we get to that. Alright, so we don't want this one anymore. Okay, so this is the RTI from the handler. I'm going to turn that off. I'm going to let myself die again. Okay, so here we are. So interrupt mask is still 0. Still 0. Now let's see if we get to that instruction that would have. Nope. So it wasn't that one. So Pyro, you said set I. Is that valid? What does that look like? I think set I would be an OR CC. Because you know, like there are instructions that are like higher level instructions that the disassembler, you know, there is no real set I, you know. The only things really that operate on C are ANSI C. Oh, you meant the 0x1e. Oh, right. Yeah. That means the set I. Yeah, exactly. True. That makes sense. Okay, so it wasn't there. Anything else we might find of use in here? So this would actually turn off the bits. All branch carrying. Well, at least in this disassembly, that's the only thing that would help me. So, what is it? So there's something about stepping 100 instructions, stepping 1,000 instructions. Let me see. It's like if you hold shift or something. Where was it? I read somewhere about... Hey, Fake Pyrie. Yeah, this is Malban's integrated development environment, debugger, everything Vectrex that he worked on for a really long time. And I'm trying to take advantage of it to understand what's going on. Okay, that's what it was. I don't know what GUI toolkit it's using. I mean, it's done in Java. I don't really know much about Java, so I can't really answer that question. Maybe you guys know, if you guys know Java. You think it's swing? Could be. Maybe there may be even a way to change its look. I don't know. There's these themes. I don't know. So, okay, so the first time we get here, actually, this is the BIOS routine that's about to do the refreshing loop. In fact, the IRQ mask is actually still 0. So last time I ran this, that was not the case. So that's kind of interesting, right? and I have a breakpoint on RTI. If I put a breakpoint here, so this loop will keep running for a while. I'll turn off this one. This is going to be very slow if I do this way. And see, now when I reach here, it's 1. So what does that mean? Does that mean that the interrupt handler did run? What the hell? Okay, that's very strange. Let me go find that RTI again. Maybe I think I disabled that breakpoint. I believe that would enlighten me a little bit here. So it's at 0C1D. No? Why can't I? Oh, here. So here's RTI, mask is 1, we step, mask becomes 0 because it popped off the state. So that's what I was saying, it should happen. I mean, if the mask is 1 in this function, that would tell me that this function is actually being invoked by the interrupt handler. Is that possible? I don't know if I have a trace of that. So this is RTI. So let me see if from now I'd like to get the first address of the interrupt handler, which was 09B9. See, I don't have it. 09B9. Just choose some random instruction and see if we reach it. You mean inside the breakpoint? Is that what you mean? If I can't change it here? I'm not sure how I would be able to change this. Maybe if I go to a memory view, yeah, I know. I don't know how. Cast to byte. Cast to code, I see. Ungroup. Join number. Maybe, okay, I see what you mean. Join. I don't know what I'm doing. Here. 09 10. Can't tell it that it's code here. Oh man, this is frustrating. I need to. The other thing I can do is try to like catch at least one instruction in here that hopefully is correct, you know? So I know what you mean. There's got to be a way to tell it. Oh, okay, cast a byte, broke it up. And then here 09B9, I say cast a code. This looks good. Okay, so let's remove this. And let's see, if we continue. Oh, there we go. I think we just... Is that where we're at? Yes, and then you see, then we hit this because in there, it's calling this code. And then there's the RTI. That's the beginning of the interrupt, and then we call here. Okay, so now what I'm thinking is, what the game is doing is, it's in its interrupt handler, it's going to do the recal, because it's doing the whole render. There is a moment between the time when we start the game and the time it gets that first interrupt that maybe there's one call to recalibrate that's coming from, I don't know where. Yeah, that's the question. Where is it coming from, that call? I'm thinking that, like, okay, so the thought that's crossing my mind is maybe there really is, like, in this game, you know, when you have that start screen and you press play the second time around, maybe it really does do like the wrong thing in the sense that it would end up calling the interrupt handler during this recalibration that doesn't come from the interrupt handler. And maybe on real hardware, and if it's emulated correctly, it's okay. You know what I mean? Maybe it just ends up working, but for some reason in my emulator it doesn't. And, you know, one thing that comes to mind is, let me think. That makes sense? It's gonna go and start running the interrupt handler. Okay, before I go down that path, let me just make sure I'm right. Is there a way to like disable breakpoints without actually deleting them? Because I would love to like just temporarily disable my breakpoints here without losing them. I don't know. What if I do play? What if I close this window? Does that work? Pause, go. Yeah, so Sort of. So Pyro, you're asking, the issue in your emulator is that the IRQ is called within the recal function when it's only supposed to poll, yes. But the recal function is called from the IRQ subroutine, yes. So I think what happens is that there is a small window when when you like are at the play screen. Like the game wants to completely control the rendering, and when it does, it calls the recal, right? That's part of the thing. You recalibrate and then you start drawing vectors, and it does that in its handler. And my question is, first of all, what else calls the recal? Because I know the recal gets called in a few different places. For example, it does get called from within the BIOS. Let me see. No, maybe not match case. So it gets called at the beginning when we start, but that's probably not what's happening to us. It gets called in warm start. Jump here to restart the Vectrex without reinitializing the EOS. Like I'm wondering whether there's a call that's being made when we start, before the game actually kicks in and it starts doing its own IRQ handling, where it is indeed doing the weight recal before the IRQ handler has kicked in. You know what I mean? And that maybe on real hardware that's what happens, and it's still okay. Like it's just, it's weird, but it survives that. And in my emulator, I somehow get stuck there. Here's another jump that happens in select game. You see, actually this routine is probably what's happening. See, I think this is the routine that probably gets called. Routine provides game with the means for allowing the player to choose the game number he would like to play and the number of players. So this looks like what's happening, right? We're in here, most likely, and then we press go and it does this weight recal. And that is the weight recal where we have the interrupt mask still set to 0, and it ends up calling the RQ handler. That's my guess right now, that's what's going on. Is there any other place that would be interesting? No. Yeah, almost certainly it's this here. The thing is, I'm a bit annoyed because I don't want to lose my breakpoints, but I think I have no choice. There's no other way. I either delete them. There's no disabling of breakpoints as far as I can see. That would be super nice. Unless there's a way to run without hitting breakpoints, which is the last thing I was looking for. Yeah, I'm gonna do that, Pyro. Just that it means right now I need to lose my current breakpoints completely just to even get there, Unless there's like a way for me to. He had I'd like to get that. Let's go back to the help, where he had a way to enter instructions. I guess it was the bottom of Dissy here. I think there's a bug. You see how it keeps... Oh, no, they disappeared. Breakpoints, registers, Vectrex, tracker. Where do I get the disassembler? Oh, here. No? Cody, Vecchi, Vedi. Yeah, I know. Oh, okay, those are my windows. I see what you mean. Oh, I see. So I was looking in the wrong place. Vectrexy, Vedi, Cody, Vecchi. Whoa. That's pretty nice. Where was it? Window, Tools, Starter, Vectrexy, which is what I have here. This thing called VEDI, which is not what I was looking for. Is it? I'm looking for DISI. Here, maybe this? Associate DISI with Vec. There we go. Okay. Found it, found it. All right. Now, here, I can enter commands, right? Sweet. Hard reset. Did I lose my break? I lost my breakpoints. Alright, well, let's just see at least if we get here. F7, 9-3, F7, 7A9. Why does it say F7A9, but it's actually F793? Isn't that weird? F7A8 to select game. Okay. F7A9. I guess it's wrong? Okay. F7A8. Alright, so let's look for this call here. F7 C4. So I guess we'll do what we did last time, cast to byte, and I just lost my place. F7, C5, cast to byte. F7 C4 here, cast a code. BD F192. Hey, wait, that's not the same. Oh, there's F192. Here's a 67. Why? I don't know. Let's just put a breakpoint here. Maybe it'll figure it out. Maybe what I can do is I can do what I always do with mine and like write down commands, you know? So like if I can't save them, at least I can re-enter them. And in fact, maybe if I do that, then I don't have to worry at all about doing this kind of breaking up of instructions, right? Okay, so it does like that. Don't know why it puts $2 here, but okay. So this is setting a breakpoint at the wait recal in select game. And then we want Bedlam notes here. Start of our key handler. RTI. And we wanted also those first few that could be interesting. Although these I guess are not that interesting anymore, but maybe just this one here. Okay, so now I have a way to set these, but let's see if we actually hit that breakpoint. Let's continue. So we don't. Is that right? Oh no, look, the breakpoint somehow did not get set. Soft reset. Okay, so now the breakpoint remains. Interesting. But we don't hit this, it seems. So we don't get this wait recal. Let me see. In fact, why don't we just put a breakpoint in the wait recal and see what the call stack looks like. Presumably we can do that. So that's wait recal right there. Go? No? Here's a wait recal and the soft reset. Anything useful? Okay, that's cool. I like this feature. You can click on the stack and it'll show you where you are. And then you click on the PC and it brings you back. So it looks like we got called from a do sound. Really? Oh no, wait recal here, not from do sound. Okay. It's just that it pushed do sound there. So this comes from warm start, probably. Okay, so it's running, it's doing an initial wait recal and warm start. Okay, alright, that's fine. There's another wait recal from the BIOS again. From where? Same place. So I guess we're in some kind of intro loop thing, which is fine, we don't really care that much. Okay, here's Bedlam. Player 1. And then we don't get a wait recal call. It's very weird. Why don't we get one? And I lost all my breakpoints. That's why. Yeah, so there is a stack window. Okay, this is kind of weird. I lost my breakpoints again, which is a bit disconcerting. Just want to know on this guy. Okay, so see, while I'm in this screen, I am hitting the wait recal. And when I do, you see my, down here, my interrupt mask is 0, so IRQ mask is clear. And we are doing this from, let's see the call stack. We are in the middle of select game. So it is the select game. Is that what I said before? Select game? And higher above that, yeah, select game. So we're doing the select game, and the select game wants to do this. So what does that mean? That means that during that wait recal, are we hitting our interrupt handler? That's the question, right? So let's see, if I put a breakpoint at the start of the IRQ handler, wait recal, that's weird, right? Why would we're executing wait recal here, which ends up doing that loop for the T2 thing, and if that's happening, oh no, wait, yeah, because the interrupt enable must be clear. Let's see. Yeah, it's all 0. Alright, so no interrupts are enabled just yet. That's okay. So that's why right now it's okay. Then that's why this breakpoint matters. Here's where we enable T2 interrupts on the VIA. So we put that in. I'm gonna say go, but I want to hit play. I don't know if I'll have a chance. I'm gonna have to disable this wait recal so I can actually hit go. We'll have to add it back. Alright, so here's where we enable the interrupt, and now we'll put back the wait recal breakpoints. So after this, if there is a T2 interrupt, it should go into the IRQ handler. And I have 3 breakpoints, yeah. So here's wait recal now, and I have 0 here. So this is what I was saying about there's a moment where we would hit the wait recal, and the reason for this wait recal would still, let's look at the call stack. Why are we, what's causing this? Jump to subroutine. So this is coming from the game itself. It's jumping to 04BE. Branched 04BE? What? Oh no, sorry, that's the higher up. Here we go. We are, yes, we are in the ROM. It calls a wait recal at 04D7. So it called its own wait recal. Okay. And then during that wait recal, I suspect that we will come back here. Let's put a breakpoint right after it to see if we run, do we come here before we get our IRQ handler? Don't get it. So it looks like we made it to F195 here. So we processed the wait recal, despite the fact that interrupt enable for T2 is enabled, and that our mask is 0. So there's something I'm looking at here. So something about the timers is that when you read, it actually sets the interrupt flag to false. And we know that it's reading, right? It's polling. So I wonder if, despite the fact that the interrupt enable flag is set, and despite the fact that interrupt mask is 0, because the BIOS is polling, even if the interrupt flag would be raised, it would get cleared because it's reading it. And that in my emulator, based on the order of operations, where a read would occur, but then afterwards I would update, and then that would set the interrupt flag to true, which would cause the interrupt to occur on the next frame. Maybe that's just not happening on the real hardware. Like maybe it's an order of operations thing. Now if I continue, this is the beginning of the interrupt. And then we go into the usual loop. Yeah, so that's what I'm starting to think, that that's where the bug is. I think that there's a read that occurs, it would clear a flag, but then I process the update right after that. And that is actually the order in which I do things. Let me think. Yeah, like see these two instructions here? This bit A against the via interrupt flags here. Let me see this. Would that cause a read? Is that a read? Can we consider that a read? It's not really a read. No, that's it. A real read would be actually on the register itself. But if we're just polling on the interrupt flags, unless polling the interrupt flags is supposed to reset counters, and I don't know that. I don't think so. That wouldn't make sense. Because the whole purpose of reading the interrupt flag is to know if it's up, on, or not. Okay, I want to do this again. I just want to double check that I'm right. Let's do a soft reset. Or maybe a hard reset. Okay, so we're about to enable interrupts here, 52. There it is. I do have a breakpoint on the wait recal, right? F192. See, I entered it, but it didn't get in. No? Didn't? Okay, there it is. So we did that, and then we say go, and there's our wait recal. And this is the one that I think doesn't make sense to me, is that... Oh no, it's 1 here. Why is it 1 here now? That's not... Oh, because the first time. Of course. Of course. We need to die first. Let's just continue. Okay, so now we'll set up our breakpoints. So we want recal. We want this guy for that, the RTI, and the RQ handler. 4 of them. We go. So here's our wait recal. So there's our interrupt mask 0, but interrupt enable hasn't been hit yet, so that's why we don't get anything. That's alright. We continue. Okay, we're going to remove this breakpoint for a sec. We're going to continue, press play. There's our interrupt enable. We put back the interrupt on the wait recal. We go. So here we are. Again, interrupt mask is 0, T2 interrupts are on. In here, we should enter our interrupt handler, but for some reason we don't. I wish I could put a break here. F19E. Yeah, so it's right there. See this like loop here, tuck, 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 and then eventually when it's finished, it gets to set refresh. Wait, we just did hit our, we just did enter the, okay, this makes a bit more sense now. We are indeed going into the interrupt handler during a wait recal that's coming from, there's an explicit call to wait recal here. Coming from the game, and during its loop, see here, we were here, now we're in the middle of a wait recal. Wait, am I right? Where are we right now? PC 09B9. Yeah, that is start of IRQ handler. Okay. Okay, so we are entering the IRQ handler. So this is what I was saying before, that it's actually normal behavior. Isn't it weird? Like, that's what the game's doing. The game is explicitly calling a wait recal here, and then that's actually getting interrupted by its own handler, which we'll call wait recal. then somehow that works. So do we get another wait recal during this time? Let's see if we continue. Yeah, there's our wait recal. No. Where's PC? F192, yeah. But our stack changed. There are multiple ways that it gets cleared. Okay, so what just happened? We did get a call. We call wait recal, we got an interrupt handler, but it didn't call wait recal this time. So that's weird. There's RTI. What? Okay, I'm just finding this a bit strange here. CBDA. Okay, I think I can't trust what I'm seeing here because the stack didn't, maybe there's a bug or something in the stack here because I lost my stack when I had my RTI there. But see, we're back in the wait recal. So we did do from a wait recal, we actually ran an IRQ and then we're back from it. So it's more like I'm not handling that properly. I think that's all it is. Now the question is why not? Does this have to do with like cycles? Ah, that's an interesting theory, Pyro. That is a very interesting theory. So normally it gets cleared when you write to the counter high. It can get cleared by reading explicitly from counter low. Otherwise, I have this set interrupt flag. Did I call this? Let's see. So apparently if you write to the interrupt flag, that can clear interrupt flags. And I have a to-do here. Validate if this is the correct behavior. Okay. So let's say, one thing we can do is we can actually validate it here, right? That's a very interesting theory, Pyro. Let's see if you're right. Let's see how it would behave here. Oh, wait, not yet. What just happened there? All right, let me set back my. Oh, I'm gonna set them manually. Those two. This one. We go. Start. Set the weight recal. Go. Okay, so here's the weight recal. I'm going to put a breakpoint on set refresh. And what I'm expecting, actually not on the set refresh. Yes, on the set refresh. I'm going to hit go, and I'm going to expect to hit my RQ handler. There it is. Let's look at the timer 2 here. See, here it already says timer 2 interrupt inactive. Interrupt enable is here, 1-1. Why is it doesn't have something similar here? Okay. We step here. Oh, sorry, this is the beginning of, so this is the beginning of the interrupt handler. Now if we continue, we're gonna get on the weight recal. So here's the second weight recal. And then the question is, do we get stuck in here? And it seems like probably in mine we do, right? But here it says interrupt inactive at this moment. So maybe it's more that. Maybe it's that mine remains active. Whereas here, as soon as the interrupt occurred, it became inactive. Let me see. Where are we? Okay, I'm going to return here. And see, we already finished this inner loop. because we waited for timer 2. And as far as it's concerned, timer 2 is still enabled. So that's the thing, right? The question is, for me, is timer 2 still considered enabled? Yeah, so that's what you were saying, Pyro. Here it's clear that the timer is still considered enabled. Okay. So let's see what my emulator is doing. No, not yet. Okay, so we break here, and let's do something similar. So for me, it's actually break, not breakpoint. So I'm just gonna copy this. Like it's just B for me. And I want these 3. And this one here, I'm just gonna wait until I hit go. So here we are, we're broken at 53. I'll add this breakpoint. So here we are at F192. High is low, and what I expect now is if I run, I'm gonna hit the breakpoint for wait recal. No, I am at the breakpoint for hit recal. I expect that I'm gonna run and I'm gonna hit the breakpoint for the IRQ handler. You know what? Let me just do something that's going to help me debug this. This will be IRQ handler or IRQ start, and I'll say Bedlam IRQ end, which is the RTI instruction. I'm just going to use my own labeling system to help me figure this out. Bedlam enable T2 int and wait recal. I think I have wait recal. Yeah. Oh, unfortunately I don't show it here. I should do that when I break. It would be useful. Yeah, this might not even help that much. But still. Thank you, Pyro. Appreciate it. I am pretty happy with it. Okay, so as saying as now, I'm going to do a continue, and here we go. We are breaking at 09B9, which is our, yeah, see, unfortunately it doesn't, maybe I should make that change at some point, is to show if we're stopped at a breakpoint and I know what the label is, I should show what it is. But here we are, we're in the beginning of the IRQ handler. And what we expect is that another wait recal is about to get hit. There's F192, that's the wait recal we're just talking about. And I suspect that Pyro is right, that we are already screwed because our T2 interrupt will say that it's cleared. To know that, let's go to F19E. F19E. Step. Oh no, look. We didn't go back to F19E here. We continued. We're doing the F1, where are we? F1A2. Yeah, set refresh. So this means that the T2 is still considered expired. And we can actually check that by just putting a breakpoint here in the via and putting on it like update or something. I'll just do one step here and let me go see what our T2 looks like. Now it says interrupt flag false. Did it just become false? I mean, we passed this bit A here. We just did a read. See here? No, it's got nothing to do with it. So maybe now it's become false and that screws us up, you know? Bit A, $0D, interrupt flag, we're reading it here. Why would it have become false? It should still be true. Okay, let's do this again. Yeah, I know, I was thinking the same thing. I should totally do that. Here, you know what, let me add it to my to-do list. Okay, so we're there. Okay, so actually I want this one disabled. F19E. Just for a moment. Okay, could I just... Whoops, not 0. Disable 4. Oh, and F192. Okay, so now enable 3 and 4, I guess. So here's F192. F19E. Okay, we're just going to keep hitting this one, so let's disable F19E. Okay, so this is the interrupt handler. It's going to call this. And now it's tricky. We're at F19E, and let me put a breakpoint because we're about to run we're going to read interrupt flags here. Step. So timer 2, see interrupt flag is true. So it is true right now. I'm going to put a data breakpoint to catch when my own. Yes, I'm inside the wait recal of the IRQ. Exactly right. So something is going to make this false in my code. I'm going to put a hardware breakpoint on the address of the interrupt flag here. So this will return a result that has that bit enabled. Aha! We just got a write to timer high here. So that was like the next instruction. F1A5. Really? Op store. So we're writing to T2 low at F1A5. Let me see. Into timer 2. So this here resets timer 2. Set refresh. This routine loads the refresh timer with the value in C83D to C83E and recalibrates the vector generators. So this is correct. So when we're done the wait recal, we load up T2 with another timer. And then we jump to recalibrate. Okay. Set refresh. So this just puts the value in there. So why is that's just resets T2. It recalibrates the vector generators, thus content be left at origin. The higher order byte for the timer is loaded from C83E and the lower order byte is loaded from C83D. The refresh rate is calculated as follows. Okay. So we're getting another get interrupt flag now. Where are we? F33D. We have another type loop here, waiting for timer 1. Wait, oh, okay, yeah, this is for timer 1. Yeah, it's because I hit my breakpoint for a timer 1 change. So that's okay. Yeah, we're gonna get probably a few of these kinds of reads for timer 1 now, so I'm just gonna remove that. So breakpoint of 0C1D. So 0C1D, see I really need to put what, I should really put the symbol name next to this breakpoint hit. There should be a $sign here. So 0C1D, if I'm not mistaken, is our end of IRQ. So we ended the IRQ here, that's good. And we're about to go back to the outer recal, right? F1A0. Yeah, so here we are. So we're about to go back here, and I guess now T2, that's it. Timer 2 is going to not have been set yet. And then during the time we wait, we're gonna get another, so that's where the bug is here for me, right? We're just gonna keep looping here infinitely. But why doesn't that happen in V-Day here? Let's see. There's the RTI. I step back, and we are at F1A0. See here, timer 2 says interrupt active. Don't get it. But it looks like you're right, Pyro. It looks like the difference is that in V-Day, the timer remains active, whereas for me, it became inactive in the write to T2 low. Why wouldn't that have happened here? Let me try and compare again properly. Just want to double check because I lost a bit of context here. Hey Brahim, how's it going? I'm looking at the clock here, it's already midnight for me. I should wrap this up. Hey, thanks man. But this is not mine. I assume you're talking about this tool here. This is another Vectrex IDE that was written by this guy called Malban, who spent an enormous amount of time putting together this very cool system. Oh, you want a URL for this? Sure, no problem. So this is the blog. And you can download it from there. So yeah, check that out. It's super cool. Malban watches my stream sometimes. I'm sure that he'll eventually see how I spent the entire stream in his tool. And it's really hats off to him. This is an amazing amount of work. Okay, so focus here. I put my breakpoints in. So here's the weight recal. I'm gonna put a breakpoint here. Start of IRQ handler, which calls weight recal, which gets here RTI step. We are now at F1A0. So the store D instructions would store both low and high. So here's something I just noticed is that we hit our interrupt while we were on this instruction. Man, I'm getting confused. Hold on. Why did... Why is it that this guy didn't go back here? Why did we end up going to the next instruction? Because when we were here, the first time, it's very confusing. Let me actually draw it. Back to here, Bedlam notes. So we got wait recal, which then ends up calling hierarchy start, let's say, which calls wait recal. And in there we've got this like the polling loop, right? Which is basically these two instructions here. And then we end up here. T2 is enabled. And then I think that's the thing, right? We write to T2 high-low, right? Reset T2 interrupt. So T2 interrupt disabled. Then IRQ end. And then I put this here. So here's what I don't get, right? We're running this first one and we're like looping through here. And as soon as, like we're on this instruction, that's what happened for me. We're at F1 A0 and T2 raised. Then we immediately, push onto the stack the current state. And just to be clear, like I would have run this instruction and T2 would have been still not enabled. So when I come back, I should really branch to this. Does that make sense? Or maybe not. Let's see. What happens if T2 became enabled as a result of running this instruction? Let's say in the worst case scenario, I'm right. We come here, T2 was not yet enabled, and then we execute this instruction. Oh wait, that's it, isn't it? See, when I execute this in my emulator, this takes a certain number of cycles, right? First thing I do is I will execute this operation. And let's say interrupt enable was, like the interrupt is not enabled yet, right? So I end up setting up my flags to say it's not yet enabled. Then after, I actually update via. And then all of a sudden, the interrupt might get enabled. And then we get screwed. You see? Because then we come here, while we execute this, before we even get a chance to execute this, we end up doing our queue handler. It does all of this. T2 becomes disabled. And when we come back, we're here, and it remembers that the interrupt was not enabled when we did this call. And therefore it goes back to here and we get into this infinite loop. Whereas the difference with Malban, and just notice, is that when he comes back here from the IRQ end, it doesn't jump back. It doesn't keep looping. So it means that it's a timing issue, that It's like I have a, it's basically chicken and egg, right? Yeah. Yes. Oh man, that's tricky. You understand, right, Pyro, what I'm saying? Yeah, exactly. It's all about when. It's exactly what I'm saying. I execute the opcode, and then immediately afterwards I update the via. It's actually very easy to see in here, in this execute instruction. So you see, this is where I execute the instruction, and then right after that I update the via based on the number of cycles from that instruction. But you see, that's where I get screwed, because I make the assumption that the next instruction will see the state of the via, except that completely gets hosed when it's an IRQ handler that comes in and messes up the state of the via, right? The thing is, so if I were to reverse these, would that change anything? Because I don't know how many cycles to update it for, you know? Or maybe it's like if I request something from the via, I need to immediately update it for that many cycles to get its current state. But that's the bug. I don't know what's the right fix for this. I'm trying to think. So basically, we do bit A on the via interrupt flags. We store in our CC that T2 is not yet enabled. We then update the via, and T2 becomes enabled. That, then during the next instruction, which is supposed to test, it ends up calling the IRQ handler. This ends up screwing up the state of T2. Because this ends up setting it back to disabled. When we come back, this says, well, I remember that it was not enabled because we stored that on the stack, so we come back up here. And then when it queries it again, it's still not enabled. And then we end up getting stuck in this infinite loop, because while we keep looking for it, as soon as it becomes enabled again, once again, we have the same problem. We go into our IRQ handler, and then this becomes an infinite loop. Now, what is the right way to address this problem? I guess what we would want is no Pyro. You know, the interrupt flag register is part of the VIA, so it's, you know, it's got like nothing to do with the CPU. Honestly, this is like the kind of thing where it's almost a miracle that it works, you know, on real hardware. I could almost imagine like that Bedlam might be a game that sometimes locks up because it's like so timing based. No, it's okay. I mean, the VIA is just a separate chip, right? From the CPU. I'm gonna write down the problem, so at least I have it written down. Starts looping, waiting for T2 enable flag. We execute bit A, which stores that T2 is not enabled. Then we update VIA, which enables it. Enables it. Then we execute BEQ, but then when we are about to execute BEQ, we end up triggering the IRQ handler. The IRQ handler then runs and eventually disables T2 interrupt. When it returns, the BEQ will go back, will jump back to the bit A because T2 wasn't enabled and we start all over and end up in an infinite loop. Okay, so that's the problem. I don't know exactly what the fix is. Yeah, so it seems like that, right? But then what's the number of cycles I pass it, right? Do I remember the number of cycles from the last time we updated the CPU? Is that what we're supposed to do? I mean, maybe. It's kind of crappy, you know, having to remember last frame's cycles. But since we see that the CPU depends, like you can even see here, I'm asking the VIA for its IRQ enabled. This will come from last frame's update to the VIA. You know what I mean? I guess that's all I could do. Let's try it. Let's see. Because I think, yeah, Pyro, I was thinking the same thing. Like, maybe I have no choice but to flip these two. Because if I were to flip them, that would fix the problem here, right? I would update the VIA from last frame's cycles, and when it would say, oh, interrupts are enabled, I would end up storing that it has been enabled here, And probably during the execution of this instruction, I would end up tripping the IRQ handler. But at this point, I've already stored that it's enabled. And when we come back, we come here. And then everything would be fine. So yeah, that seems like the right thing to do. It just kind of sucks because it makes this a bit more complex. You can't read the opcodes. I know what you're saying, like kind of look ahead, right? What's the operation I'm about to execute? Update the VIA for that much, then execute. But the problem is that some of those operations, we won't know exactly how many cycles they're going to take until we execute them. It's actually very difficult to figure out. It's not just like a table. It depends on a whole bunch of factors. So in the end, you know, I know how many cycles because I execute the instruction, and then certain branches, certain conditions add a cycle or add 2 cycles. And in fact, some of them are... Is it impossible? It's hard. But yeah, for sure, if there was a way for me to say, well, how many cycles would you execute, but don't execute them, you know? But yeah, there really are, there's some complications with the cycles in the CPU. Yeah, this is probably where the extra complexity comes in. It's the indexed mode. In here, there's a whole bunch of special cases. You can see them here for how many extra cycles are going to be executed, you see? Depending on like the exact bits that are set for the indexed addressing, you might add 1 cycle, 2 cycles, 3 cycles, you see? 4 cycles, 5 cycles. And a lot of the time it's like, to know you want to actually execute the instruction because it does a fetch, and yeah, it's possible. I could totally, you know, write this, but I would have to like kind of split my CPU code into simulate an instruction versus actually execute it. And it's not really set up for that right now. I could do it though, you know, that would be another way. It would probably be more expensive because I'd be kind of doing a bunch of work twice. So I don't think it's worth it necessarily. Okay, let's try it. Yeah, there is no easy way. The only way I can see is that during the CPU's instruction, let's say, if the instruction is about to make a read, if I could pass to the read how many cycles so far the CPU has executed, I might be able to do it there, but that's actually quite complex, you know, because it changes the way my whole memory read-write thing works, you know. Anyway, it's possible. So let's just see if this works. Didn't work. Okay, I missed something. Thanks, Brian. Catch you later, man. So we ended up back in here. Okay. Triggering a timer interrupt too early. I don't know. The way I saw it, if I go back to the code, maybe if I just repeat it, that might become evident what's going on here, to me anyway. Like maybe I'll see my mistake. So what I'm thinking is that we want to execute this bit A, right? When we do it, it's going to set, you know, we're using branch if equal. So branch if equal is going to look at the 0 register, I believe. Oh yeah, it says the yeah. See, it's going to look at 0, and it's true as long as 0 is not 0. So if 0 is 1, then we make the branch. So 0 is high, we make the branch. Which is why we're making the branch here. See, 0 is high. Now, going back to here. So I was going to say was that the idea behind updating via beforehand is we update it, and let's say that sets T2 enabled. Oh, sorry, I thought I totally missed what you wrote. What if you increase the CPU cycles by one instruction which has the most cycles, and then subtract that? Oh, I see, yeah. You might trigger a timer interrupt too early, yeah. I see what you mean, I see, yeah. Yeah, it was funny, I was thinking about that. I was thinking about like, yeah, like trying to kind of almost give a little extra time and then kind of correct for it, but yeah, it's gonna have some wonky behavior, especially because updating the VIA, the number of cycles you pass is also what's responsible for moving the vectors, you know? It's like super important that the timing is correct for getting the vector drawing to be correct. So I can't really undo time, you know what I mean? If there's vectors and there are lines in the queue that as a result of updating the VIA, it's not easy to undo that, you know what I mean? I could do, I guess, correction over time like I do, but I don't know. So anyway, if I continue what I was saying, I'm updating the VIA with last time we updated CPU, how many cycles it took, right? And let's say that we update the VIA and it sets the flags to true, and then we do this. I think the problem though is still that even let's say we update it and it's false, and then we do this. It's not yet enabled. Then on the next one, we execute it, it becomes enabled, and then we're about to do a branch equal, and we jump, we're fucked anyway. Yeah, that doesn't fix anything. Yeah, so it's the same problem. How could we fix this? So I was saying is like, if this instruction runs and it's not enabled, okay, then on the next time we run this instruction, we use the number of cycles of this guy to update the VIA. It says, oh, interrupts are enabled. And then when we try to execute this, we end up doing our IRQ. And when we come back, it's still disabled. So yeah. I think what's happening, and it's very difficult to catch this, right? Because it would mean catching the moment the IRQ happened. On the stack, we would see, let's say, this address. And at that moment, what's been stored in CC is what we would need to see. But it's hard to see because it's been pushed onto the stack, right? Well, I suppose it's not true. I guess it's been pushed, but it already has its value at that moment. Wait, what am I saying? Yeah, it's about the 0 flag. Would it have pushed the 0 flag low at the moment that that happens? We can look at that at V-Day. That it would have to be that. Whereas for me it would be high. Let me just see if I'm right. Disable star. I really should stop. Well, I care about CC as well, right? Because it's the result of this the result of this bit A here will update the CC0 flag, right? And that's what's used when we execute branch if equal. You see? And that 0 flag depends on, yes, on the value of the interrupt. And so it's all about what happens. Yeah, I don't, you know, I mean, if this is the one that causes the interrupt to occur, we should be okay. The problem is if this instruction is what causes the interrupt to occur, then we are in trouble, as far as I can tell. So let me see if I can figure this out. Like this. What just happened? Ah, fuck. I missed it. Yes, I know. What I'm saying is that what I think is happening in VDay is that when it executes this instruction here, the interrupt flag, the timer 2 is enabled, and that sets 0, that unsets 0, puts 0 to Z in the CC flag to 0, and then that gets pushed on the stack when it jumps to the IRQ. Okay, it's like we come here, and then it pushes that onto the stack, and then it runs the IRQ. And then no matter what, whether T2 is enabled or not, when it comes back to F1A0, this branch equals will say, oh, we're not equal, right? Because Z is low. Why? Because it was pushed on the stack before we jump to the IRQ handler. Because at the moment that it ran this, the interrupt flags said that T2 was enabled. You see what I mean? Yes, because of branch if equals. Now my thing is though, is what happens if this executes, T2 is not enabled, then during the execution of this, T2 becomes enabled, right? Then we're screwed because we didn't get a chance to store that effect of T2 being enabled in the 0 flag, because during the execution of this, we immediately don't execute it and go to the IRQ handler, and we're back into I'm screwed, you know? See, here, this is where we end up about to run the branch if equal. I think we didn't run it yet, but here you can see that, yeah, we didn't run it. We were about to run branch if equal, but Z would have been high, you see? And when we push all the registers to the stack, we would be pushing Z high. So we're screwed. That's why I'm screwed in mine. But what's happening in VDay, I don't know. Maybe there's something like some special handling for instructions that deal with... No, I don't see it. So let's see. Let's try and replicate this here again. Well, that's the thing, right? That's what I'm thinking. I wonder if Bedlam is one of those cards that maybe does bug out sometimes. Okay, let me just break here. Okay, so there's wait recal being called explicitly. And then there's the beginning of an interrupt. So let's see, can we look at what our registers look like? Okay, so 0 is already low here, you see? I don't know if I can trust this stack, but basically 09B9 is the beginning of the IRQ handler, and according to the stack, oh wait, maybe I'm reading this the wrong way. Yeah, see? Okay, we were at F1A0, that's what got pushed. So see, the branch if equals here got pushed, and yet Z is already 0, which means that the bit A that just ran before saw that T2 got enabled. Yeah, this is the case where, what I was saying, where this instruction gets a chance to run when the IRQ is enabled. It stores that, and then this is the instruction that gets run, and we end up going to the IRQ handler. If that occurs, we're good. In my case, it seems to be that we... Oh, sorry, actually, that's not quite true. If we run this, and it happens that the T2 happens to be enabled now, but if it's not, we're screwed here too. So why is it... So it's really like a toss-up, right? If the bit A sees the T2 being enabled, then we're okay. If it doesn't see it, and it happens on the next run of the instruction, unless no. Unfortunately, guys, I'm gonna have to stop here. We're close. We know the problem. I just don't know. Like, I don't understand. Is it luck that it works in V-Day? I mean, it sure seems like that, right? Like, yeah. I mean, everything points to that. I could be wrong, but here we are. We're about to run the handler, and at this moment, Z is 0, which means that, and if we look F1A0, it means that we push this on the stack. It means we just finished executing. That's actually what it means, right? It means we finished executing bit A. If the instruction we push on the stack is F1A0, and in running bit A, we notice, hey, you know, the T2 is enabled, which wait a minute. I just thought of something. We notice that it's enabled when we run it. Yeah, so we notice it's enabled. PC has this. We're about to execute it. Yeah, okay. But what if we ran this and it wasn't enabled yet? And we came here. And we start to execute this one. Branch if equal. What would the PC be? Yeah, okay. So okay, I'm gonna stop. I need to step away from this problem. I'll think about it, and maybe on Thursday night, if I stream, we can get to the bottom of this. So sorry I can't fix this. I really wanted to fix this. I feel like at least we know what it is, right? I'm pretty sure we know what it is. There's still a couple of question marks around how come it works in here. And I mean, it's 100% in here, right? It always works. So there must be some small or very important detail I'm missing. But I feel like we're in the right vicinity. So we made some progress. So yeah, guys, thanks for watching, and I hope to be back in a couple days. And if not, well, I'll be posting it on Twitter. So thanks a lot, and I'll catch you next time.